Okay, so we'll see how this goes. But what I've been doing in the WebGPU stuff, hi, how's it going by the way, is I have been doing this ray tracing. And I've got this ray tracer, and come on. It sort of works, and we've got models. We can, oh, there's two of them. Okay, we got this one. It sort of works. We handle models, and we handle heaps of models, and even though it's not a very imaginative transformation, they can have individual transformations. It'll work, it'll handle that just fine. But there's a lot of things it can't do. So at the moment, we don't have textures on these models. We only have one sort of model. We don't have different types of models. And also, at the time that I wrote it, I was working under time pressure, and I was just trying to get something done. So that has made it to the point where this thing sort of works, but it's hard to extend it. So before I go and extend my ray tracer, what I want to do, and I'll take a few videos to do this, is I'll be going through the features of my existing ray tracer and abstracting some of these things out. Because for instance, I'll get this out of the way, if I look at my renderer class, there's a lot of code in here which frankly just shouldn't, oh by the way, I just quickly fix this up. Go to tsconfig, remove this line here, and that should fix it. Okay, so there's a lot of code here which frankly should not be in here. So stuff like this, it's not the worst, but we can get it out of there. And then definitely stuff like this should absolutely not be in my renderer. This makes it very difficult to parse the code at a glance, and it's just trickier than it needs to be. So what I'm going to do in this video is I'm going to be focusing on pipelines. I'm just going to get pipelines, make a pipeline class, and then that'll be it. And then in the next video, I'm going to have a look at buffers, and we'll just sort of take it from there. And then I'll start re-examining this ray tracer and making it more general. But yeah, so settle in. This might take a bit of time. We'll see how it goes. So I'm going to make this pipeline, sorry, not pipelines, oh my goodness. I'm just going to make a renderer folder just so I don't have heaps of different. You're not going to let me rename it? Okay, just so I don't have heaps of different source files here. So I'm just going to grab everything which sort of has to do with rendering, cube material, and the rest of this stuff is a little more geometric. So I'm going to leave that as it is. Now, it's probably a good idea to just be periodically running this because it refactored everything except for the shaders. So I'm just gonna quickly pop into the parent folder. Okay, that works. Happy with that. By the way, side note, there are some little like black dots where triangles are meant to be there and they're not rendering. I don't know what's happening, but that's not my focus today. But yeah, I am aware of that. Okay, so what I'm going to do is I'm going to, and you know, I've said this many times, this is going to take a while. I'm going to take all the content of my renderer and I'm going to dump it into this pipeline function because these things are going to use a similar sort of programming model. So I'm going to have the class pipeline. I am going to store a device, but I'm not going to store this other stuff. None of this stuff I need. So the things that I want to achieve with this pipeline is I want to wrap up the pipeline object and the pipeline layout. So pipeline is a literal object, but then it should also have a description of the general shape of data that we take in. And so I'll have pipeline and this bind group layout, and those are the fundamental objects that I'm working with. But if I have a look here, I see that I have a screen pipeline, which is a GPU render pipeline, and also a pipeline, which is a compute pipeline. So what I'm going to do is I'm going to make this a generic class that can handle a bunch of different pipeline types, and it's going to specify that. Another way I could do this is by chaining these types together. And if I'm honest, this is probably the better way to do it because it's more specific than just a fully general class. But I like the generic class notation, so I'm going to work with that. Okay, so we've got some sort of pipeline and some sort of bind group layout. And then in addition to that, if I look down at the functionality here where I create this stuff, sometimes I'll be binding the same sort of resource, but I'll be binding it to, different types of pipelines, and sometimes those function calls are going to be slightly different depending. So what I'm going to do is I'm going to have a few things. I'm going to have what I call visibility, and that'll just be a number code that indicates, we can think of it as which sort of shader stage we're working with. And just for convenience, this isn't the only way to do it. One way to do this is we can specify every time we are going to add an object type to our pipeline layout, we can explicitly specify the binding type. Or if I look in here, these binding types are always strictly increasing. So I'm just going to, we'll say binding. I'm going to have a variable which will be incrementing every time. So in terms of data that we take in at our constructor, we're going to need to take in a device to store, to do the building work later on. Then we're going to need to specify the basically which type of thing we're making. And there's one more thing, because in my programming model, I'm going to be incrementally telling the pipeline about different asset types. So I'm going to have an array which stores all of those asset descriptions, which will be built up step by step and then read all at once. So I'm going to have, I'll call this entries, and this will be an array of GPU bind group layout entries. Not too big at all. Okay, so stepping in, first thing we'll need to do is save the provided info. Then I'm going to need to initialize a few things. So for one thing, the entries, even though I've specified I've got that array, that does not automatically create an array. It just sets up the expectation that that thing is going to be an array. And this will actually create that. Okay. And I'll give myself a starting value for the binding. Just double checking everything. Yeah, I think that's probably fine. Okay, this initialize function I'm going to completely remove. And then, same for setup device. That's fine. Okay, make bind group layouts. That's going to be a singular, not plural. So looking in here, I see that there are a bunch of different types of resources that I'm bringing in. Specifically, sort of three types. We've got 2D images, buffers, and cube maps, something like that. So I'm going to declare some functions. I'll go add image 2D, add buffer, and then, okay. So this is going to be pretty specific to my implementation. If my implementation changes in future, I will pop into this code and change the code. And yeah, please feel free to adapt this to whatever implementation you're running with. So what I'm going to do is I'm going to test which sort of thing we are. So are we a compute shader or a rasterized shader? If we're a compute shader, we're going to do one sort of thing. Otherwise, we're going to do something else. And that's just in the case of the two-dimensional image, because if I look down here at the data that I have existing, the only sort of data that I specify here in the screen shader is a two-dimensional image. So I can go ahead and grab this stuff, and I'll put that in the else case. And here's what I'll do. I'll take my entries and I'll put on a new one, just like this. Yeah, that looks pretty good. So in the case here, we've got a sampler and a texture, so we simply need to put in two objects. It is what it is. So then what I'll be doing is pretty similar. I'll be going down, oh, by the way, I can go in here, and that's it. I've handled all my cases. So I can actually replace this. Replace this call, just like that. Cool, okay. Looking on the right, we have a bunch of things still to handle. That's totally fine. Okay, so then I'm just going to look in here and say, well, here I'm making a two-dimensional image. So I'll go ahead and grab that entry description and put that in here. And while I'm at it, I'll just make a generic thing. Because I know that to add a buffer, it'll be something very similar. And to add the cube map, I'll actually be doing it twice for the texture and the sampler. But otherwise, yeah, that looks good. So now we'll get specific. As a matter of fact, we can copy this over as well. I don't know how entertaining this video is going to be, but it is something that needs to get done. Okay. Alrighty, so looking in there, that's probably fine. Right, so add buffer. So if I look at the cases where I'm adding a buffer, there are sort of really two cases, either read-only storage or uniform. And in all those cases, we don't have dynamic offsets. So what I'm going to need is I'm going to need some sort of type description, which will either be read-only or uniform. Okay, so we're getting an error at the moment, and that error is saying, hey, you're giving me a string. I expect a GPU buffer binding type, which is very strange because that is literally like putting in a string literal would work. But what I'm going to do is I'm simply going to cast it buffer binding type, just like that. Okay. And this is probably fine, so we'll go has dynamic offset is false. just like that. And then I'll just minimize. I've got this cube image. Okay, so for the case of a cube image, we've got the texture and then the sampler. So I'll do the sampler. So it's not giving any options, it's just saying, hey, we're going to have some sort of sampler. And then here, for the texture, we'll have, what is it, view dimension? Is that it? Yeah, view dimension, and then cube. Cube only. Okay. Look, that is probably fine. Yeah. Okay, so then looking down here, we'll say that we've got some entries array which has been properly populated with all of these descriptions. Other than that, these things are the same. The behavior is the same whether we make a compute or a rasterized pipeline. So I'm just going to replace all of this. Just like that. Okay. And then create assets. None of this has to do with pipelines, so I'll just get rid of it. Same with bind groups. That's not a pipeline thing, but this bit most definitely is. Okay, so this make pipelines function, I'm going to replace, I'm going to call that build. And if I look at this very carefully, first up, these lines where we make the pipeline layout, it's the same. So I'm going to get rid of that. And I'm just going to call this layout. Okay. And now we are starting to get into different behavior, because we're going to be either creating a compute pipeline or a render pipeline. So we'll say the same as before. Okay, right. So I'm going to spiral into this one bit at a time. So in both cases, we're going to be setting that pipeline variable. Now it's going to complain that, hey, you're creating a GPU pipeline, but this is a data type T. And that's okay. What I'm going to do is I'm going to cast that to the T type in both cases. And then what do we have? Ray tracing pipeline layout. That is just going to be the pipeline layout, or in fact the layout. And then down here, again, we're going to specify the layout. I'm just remixing code basically. And now we're going to need a few things. We're going to need the source code. So we hover over here, it says, hey, this is meant to be some sort of string storing the source code. And we're also going to need the name of the entry point, which is not going to be the same. Like in the rendered rasterized case, we've got vertex and fragment mains. So what I'm going to do is I'm going to have source code coming in, which is a string, and I'm going to have entry points, which is an array of strings. So, okay, no problem. The way I'll use that is I'll go in here and I'll say, okay, I'm going to put in source code. And then in the case of a compute, we'll just pick the first entry of the entry points array. And then same thing here, source code for both of these. And then down for the entry points, we'll say the first one is the vertex entry point, and the second entry there is the fragment shader entry point. But otherwise, things look okay. Alrighty, cool. So I'll leave that. And that's it. We're done. There's a bunch of other functions here. I'm just going to get rid of them. That's not a pipeline thing. Okay, so now I'm going to use that in my renderer. So I'll go to my renderer, and then for my pipeline objects, I'll still have a ray tracing pipeline, but it will handle its own layout. And I'll still have a screen pipeline, but it will handle its own layout. But I'm going to go over here and import the pipeline class. And then, yeah, so I'm going to specify that this is a pipeline and give it its types, basically. Okay, so this might be a little unwieldy. There's probably more elegant ways to do it, but here's how I'm going to handle the creation stuff. So I'll go down to the initialize function, and just after I set up the device, I'll create my pipelines. So I'll stick in there device. Yeah, that's probably fine. Talking to myself. Now I know it's a little silly that the render pipeline is actually covering both stages, but this is just the way it was designed by me, I know. And the fragment shader is the only stage which really has a resource that it talks to anyway, so that should be fine. So make bind groups. You know, this is probably still fine. Yeah, I'm going to keep the same function names. Those functions are just going to become quite a bit simpler. So sort of get this out of the way. That's fine. That's fine. Bind group layouts. Okay, so here's what I'm going to do. So I'll go ray tracing pipeline. First thing we'll do here is add a 2D image. That's what this is doing. And then I'm just going to be going step by step and converting these entries into function calls. And then after declaring all of that, I will then issue the command to actually build the layout. And that's important because that needs to be done before the actual render group, before the bind groups are created. Because when we create the bind groups at that point, we're going to tell them this is the layout that you need to conform to. But yeah, so we've got that. Whoops, not ray tracing. Okay, so I'm happy with that. Now in the asset creation, is that going to work? Okay. Here I'm just specifying, again, the layouts which these bind groups need to conform to. Yeah, I'm probably going to have a look at this again in a future video. It's a little messy. This is probably fine, I think. Or maybe not. Ah, here we go. Oh yeah, okay. Oh, what am I thinking? All of this can be replaced. So I can go... build that. Now for the source code, what is that? That was ray tracer kernel for the source code. And then for the entry point, just main. And then for the screen, we had screen shader, frag main, vert main. Okay, so screen shader, probably vert first. But yeah, I mean, that's... the stuff. Okay, looking through. Right, so we've made the pipelines. Awesome. How many times am I going to say pipeline in this video? A few times more. So here I'm going to set the... try not to say it. You know what I'm saying. Set these things. Okay, that's fine. No errors. No errors, and we've got our own pipeline class, which we're using in our renderer. So I guess the ultimate test is whether this thing still works. So we'll go ahead and try that. And yes, it is working. It is working. We can go ahead, inspect, and verify. Oh, that's fine. That sometimes happens. Yeah. Can sort of... I think if I do this again, it may completely, like... Why does it do that? I don't get it. I guess that's just one of the downsides of being brave. Okay, so there we have it. In this video, I know it's not super exciting, but it was something that needed to get done for the project to move forward. So now we have our pipelines abstracted out. In the next video, I reckon I'm going to have a go at buffers, and we're going to gradually just get this into a more manageable state so we can extend it. All right, so I hope you had fun, and I will see you soon. Bye. Hi, so I just want to give a really big shout out to my channel supporters. I'm community funded. It's how, I keep things running. If you do not want to support financially or you're unable to, that's totally fine. None of that is expected. Probably the best thing you can do to support the channel is to comment on the videos. Let me know what you'd like to see, because I am trying to make the best educational content that I can, given the time constraints. So, really big thank you to Antonin Carret, Declan, Endelon Studios, Isaiah Meyer, Jason Coleman, Matthew Derick, and Moim. Thank you so much, my dudes. It really means a lot to me. And yeah, have a great day. Bye.